Nothing beats. Another video on limits. We're going to follow up the previous video. We're talking about topic, what's called one-sided limits. So let's take a look now. All right. Now, first of all, we've been looking at limits past couple videos. And we want to take note that actually these limits that we're looking at, when we write limit is x goes to a of f of x is equal to L, that's actually a two-sided limit. And that's because the function f of x approaches this real number L for values of x that are both less than a and also values of x that are greater than a. In other words, I've been saying these things like, let's look at this location of x equal to a. Look at the limit, what's going on to the right of a, what's going on to the left of a. See what's going on. Like this situation, right? We've seen this. Two-sided limit is really what this is, in the sense that as I go to a from the left to the right in the x direction, the function f of x is approaching this number L. And as I go to a from right to the left in the x direction, the function is also approaching the number L. If indeed that's the case, of course, that's the situation where the limit exists. Now, we've been saying these things, but while we've been doing that, we've actually been unintentionally actually saying one-sided limits. So that's what this video is focused on, is the one-directional limits, both from the left to the right and from the right to the left. And what conditions do we need in order to have a limit exist? So let's talk about these one-sided limits. We got right-sided limits, we got left-sided limits. Now, first of all, a right-sided limit, sometimes called a right-handed limit, if a function f of x is defined for all values of x near a, but this time only for values of x that are bigger than a. So to the right of a. And the function f of x approaches some number, let's call it L1, as x approaches a from the right to the left. Then what we're going to write is this statement right here. Limit as x goes to a from the right of f of x is equal to L1. And that's what's just said right down here. So the important thing to note is that there's this little symbol right here above the a. It almost looks like an exponent, but it's like a little plus symbol. It's just notation. That notation indicates that we're approaching the value of a in the x direction from the right. From the right. So that's from the right to the left. To the left, to the left. From the right. That's what that notation means. It doesn't mean an operation or anything like that. It's just notation. So we got a picture here to show that. Okay, so this is what we've been dealing with. Now we're just formalizing it. I'm approaching x is a from the right. So there's x approaching a from the right to the left. The function is approaching some location. Call it L1. Remember, don't need to be defined there. Just gets arbitrary close. So that's what's called a right-sided limit or right-handed limit. When we approach this numerical value a from the right to the left, the function approaches some real number, call it L1. Now, similarly, we could talk about the left-sided limit, or left-handed limit, if you will. If the function f of x now is defined for all values of x near x is a, but now with x less than a, and the function approaches some number L2, then as x approaches a, this time from the left, we're going to denote it by this. Okay, so notice the little symbol there, little minus symbol. above the a, similar to the notation we used when we approached x is a from the right. But now we're approaching x is a from the left, so instead of using the plus symbol, we use the minus symbol. So it's plus or minuses in the exponent indicate from which direction we are approaching the location of x is a. And if that's the case like this, we say limit as x approaches a from the left of the function f of x is L2. And so now we have this new notation, right? It's that we've been talking about getting close to some number a from the right to the left and from the left to the right. But now we have actual notation to indicate those one-sided limits. So graphically what we would see is something like this. And again, this point doesn't matter if it's defined, right? I just happen to fill in the dot because it is the other version of what we saw from the right. But all we care about is as x approaches a from the left, this function f of x is approaching some location, L2, and hence the notation. So now we got the setup for one-sided limits, right-side limit, left-side limit. And in fact, if those two limits, remember L1 and L2, if the right side limit and the left side limit are equal to each other, that's what this is saying right there. Limit as x approaches a from the right of the function is the same as the limit as x approaches a from the left of the function. If those two locations are the same location, the function approaches the same location from the left and the right, as we've seen, then of course limit as x approaches a, the two-sided limit, well, that limit exists. And in fact, it would be equal to L1 and L2 since they're the same value. You know, this picture. We've seen this picture. All is showing, right? X is approaching a from the left. What's the function doing? Approaching that location L2, let's say. As x approaches a from the right, function approaching the same location, hence that limit exists, since the left and right hand limits are approaching the same location for the function f of x. So it's just formalizing what we've already really been discussing thus far. Now, one thing to note, that's necessary. If these two locations don't match up, L1 and L2, so limit as x approaches a from the right is not the same as the limit as x approaches a from the left, then this limit as x approaches a, the two-sided limit of f of x, it does not exist. This is a necessary condition in order for the two-sided limit to exist. You need the left-hand limit and right-hand limit to match up. If that don't happen, limit doesn't exist. End of story. Something like that, right? See, they're approaching different locations. You know, what this is showing over here, limit as x approaches a from the left with the little minus sign there of f of x is L2. And then over here, limit as x approaches a from the right of f of x is L1. But as we can see in the graph, L1 and L2 are not the same. And hence, what would that indicate? Well, it would indicate that the limit as x approaches a of f of x does not exist, because they do not reach the same unique value, the unique real value, from both the left and right hand sides of x equals a. So we're going to look at an example here to finalize the video, just to get the idea across, just cross-checking some of our previous knowledge as well, and that is, well, here's this function h of x. See the graph that's shown in the picture. We're going to use the graph to find some values and some limits. Okay? So first things first, we'll start at part A. Well, what's h of 2? That's just double checking we know our output values. There's the closed dot. That indicates what the output value of h is when x is 2, which is 1 here. Now in terms of limits, what happens as x goes to 2 from the left of h of x? Let's go to 2 from the left. Well, what's the function doing? getting closer and closer to the output value of 2. So as x goes to 2 from the left of h of x approaches 2. How about in part C? As x approaches 2 from the right of h of x, what's that limit? Now as I go from the right to the left, this function h is approaching this output location of 1 as we see. So that would be a limit value of 1. And notice from B and C, they don't match up, right? Limit as x approaches 2 from the left of h of x is not the same as the limit as x approaches 2 from the right of h of x, and hence, because those two one-sided limits don't match up at the same x value, limit as x approaches 2 of h of x, the two-sided limit, does not exist. So we'll just write since limit as x approaches 2 from the left of h of x does not equal the limit as x approaches 2 from the right of h of x. So then we move on to this other location, and similar things are going to happen, you might imagine, at the location of x is 4. When x is 4, what's the output value of the function h? Well, we're up here now, right? That output value happens to be 4. Boom, 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 right? Okay. Now we ask the question about the limits. What's the limit as x goes to 4 from the left of h of x? Well, let's approach 4 from the left to the right. What's my function doing? Oh, it's getting closer and closer to the output value of 1. So that's 1 there. How about from the other direction? What happens to the function as we get closer and closer to 4 from the right now in part G? Well, what's the function doing? Getting closer and closer to the output value of 4 in this situation. And again, we see these two one-sided limits don't match up, and hence limit as x goes to 4 of h of x does not exist. And why is that? Well, that's since the limit as x goes to 4 from the left of h of x does not match up with the limit as x goes to 4 from the right of h of x. Right, 1 and 4 are not the same number, so that limit doesn't exist. Right, so hopefully you're starting to see, okay, you got to look at the left side limit, the right side limit. Do those equal the same thing? If so, and it's a real number, the limit exists. If not, limit doesn't exist. Now there's this last part right here, part I, and that's just to indicate the actual two-sided limit that does exist. It's asking us to figure out what the limit as x goes to 5 is of this function in general, not one side from the left or right, but both sides. So notice if I go to x is 5 here, well, it's supposed to be showing, oh, we're right at 5. And notice as I go to x is 5 from the left, x goes to 5 from the left here, what's my function doing? Getting closer and closer to 5. As x goes to 5 from right, that's this part right there, what's my function doing? Getting closer and closer to 5. And hence, in this case, the left and right side limits are the same thing. And hence, limit as x goes to 5, two-sided limit of h of x exists, and it actually equals 5 here. So there's your little video on one-sided limits. These things are going to pop up throughout the rest of the limits topics and conversations, but we got to have at least one discussion about what they specifically are and kind of why we would use them. So there you have it. Hopefully that gives you an idea of how to approach one-sided limits and how they relate to two-sided limits. But for this video, we're out. Until the next video, Math and B.